Hello everyone, this is Laju Gupta. I am teaching you infinite geometric series. Here we have to find the sum of infinite GP series with first term is equals to small of a and common ratio equals to small of r, which is given by s infinity equals to a upon 1 minus r, where r is always greater than or equals to minus of 1 and less than or equals to 1. That is, mod of r is always less than 1. Now here we have to note one thing, that when mod of r is greater than 1, then this infinite series, sum of this infinite series tends to infinity. Okay. Now we have to take one example on infinite geometric series. So we take that here we give here given a geometric progression of infinite terms, which is given by root 2 plus 1 and plus root 2 minus 1 plus dot 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 up to infinite terms. Now we are going to solve this question. Here first term is equals to root 2 plus of 1, and we have to find common ratio, which is find by this second term is divided by first term root 2 plus of 1. Here we see that the denominator contains irrational value, so we have to take rationalization of this by dividing, multiplying in numerator and denominator by conjugate of this term. So we multiply in numerator and denominator by conjugate of root 2 plus of 1. So we take product of 1 root 2 minus 1. So this is root 2 minus 1, and here we have to see that root 2 plus 1, root 2 minus 1. Then this is 2 minus of 1. Root 2 minus 1 upon this is 1, which is root 2 minus 1. Here we see that this is always less than or equals to 1. Now we know that S infinity is given by a upon 1 minus of r. So here a is root 2 plus of 1. Root 2 plus 1 upon 1 minus, we find here r, which value is root 2 minus of 1. Root 2 minus of 1. This is root 2 plus of 1 upon 1 minus root 2, and this is plus 1. So we find root 2 plus 1 upon 1 plus 1, this is 2 minus root of 2. Now we have to take root 2 as a common. So root 2, and here we get root 2 minus of 1. Again we see that the numerator is irrational quantity. So we have to take, we have to multiply numerator and denominator by conjugate of this. So we multiply numerator and denominator by this denominator's conjugate. So this is root 2 plus of 1, again root 2 plus of 1. This again, this quantity is root 2 plus 1, root 2 plus 1. This we get root 2 plus 1 whole square into root 2. Again, here root 2 and root 2 minus 1, root 2 plus 1. Now see here, root 2 into root 2 is 2, and root 2 minus 1, root 2 plus 1 is 2 minus of 1. So here we solve S infinity equals, we solve this bracket, 2 plus 1 plus root 2, 2 root 2, and denominator is given by only 2. This is 3 plus 2 root 2 upon 2. Now we are multiplying root 2 inside the bracket. This is 3 root 2 plus 4 upon 2. We get 4 plus 3 root 2 upon 2, which is required sum of this infinite geometric progression. So what another example of infinite geometric series. Here the question is, use geometric series to express this 0.555 up to infinite is equals to 0 plus 5 bar as a rational number. We know that this is recurring number. Repeating recurring number, we have to express this as a rational number. So we use the geometric progression series to represent it. Okay. Now let 0.5 bar equals to 0.555. This again we break it 0.5 plus 0.05 plus 0.005 plus this we do up to infinite. Now we again solve it, we get 5 by 10 plus this is 5 by 10 square, this is 5 by 10 cube dot 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 to infinite. Here we take 5 as a common and we get 1 by 10 square, 1 by 10 cube up to infinite. We put take it as a equation number 1. Now we solve this infinite geometric series here. Now 1 by 10 plus 1 by 10 square plus 1 by 10 cube plus dot 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 up to infinite. Here A is equals to 1 by 10 and R is equals to 1 by 10, which is obviously less than or equals to 1. Since we know that S infinity equals A upon 1 minus of R and R mod of R is less than or equals to 1. So here we use S infinity equals A. What is the first term? 1 by 10. This is 1 by 10 upon 1 minus R. R is also 1 by 10. We use 1 by 10. Here we solve 1 by 10 upon, we take LCM of that. This we get 10 minus 1 is 9 by 10. We remove this 10, we get 1 by 9. Therefore from 1, we use here in equation number 1, this is 5, and here we solve this infinite series, we get 1 by 9. This is 1 by 9, this is 5 by 9. So 0.5 bar is equals to 5 by 9, which we express as a rational form, fractional form, 5 by 9. Now we take another example of infinite geometric series. Now we take the example, sum of infinite number of terms of the GP is given 20 and the square of their square is given 100. Now we have to find the common ratio of the required GP. Now let's solve the question. Let the infinite geometric progression be AR square dot 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 up to infinite. Since we know that S infinity is given by A upon 1 minus of R, where R is always less than, mod of R is always less than or equals to 1. So in the question we have given the sum of infinite number of terms of the GP is 20. So here we use S infinity is equals to 20 equals to A upon 1 minus of R. We take cross multiplication of these two. We get A equals to 21 minus of R. This is required equation number 1. Now also it's given in the question that sum of square of their terms means A square plus A square R square plus AR square of whole square dot 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 up to infinite is given how much? This is 100. Okay. Now by the same formula S infinity equals to A upon 1 minus R, we get A means first First term is a square. This is a square upon 1 minus r. Here we get r, means common ratio of this progression is r square. So we get r square is given 100. So a square upon, here we use the formula a square minus b square is given by what? A minus b and a plus b. So 1 minus r, 1 plus r is equals to 100. So we get, by cross multiplying these two sides, we get 100, 1 minus r, 1 plus r, this is equation number of 2. Now from 1 and 2, from equation 1 and 2 we get, this is a, by squaring both sides we get 20 square is equals to 1 minus r का whole square, and from 2 we get a square is equals to 100, 1 minus r and 1 plus r. Now here we see that in the both side 1 minus r are the common terms. So first of all we evaluate this. This is 400, 1 minus r, 1 minus r. This is 100, 1 minus r, and this is 1 plus of r. Here we see that these are common terms, and this 0 remove this 0, this 0. So we get, by multiplying 4 inside this bracket, 4 minus 4 of r is equals to 1 plus of r. Now we come here. So here 4 minus 4r equals 1 plus of r. We bring 1 this side, so it minus of 1, and this take this side, r plus 4r. This is 3 by 5 of r, 3 equals to 5r, and we get r equals to 3 by 5. This is the required common ratio of the infinite geometric series, which if the condition of it is r value is always always greater than or equal to minus of 1 and less than equals to 1, whose value is always less than or equals to 1. So this is the required quotient.